right, this video is going to be about, that's supposed to be constant acceleration. All right, so we have acceleration now on a VT graph. All right, so it's going to look different than the velocity time graph. If you watch that video, it's going to look different than that. And so we're going to see how it looks different and what that means. All right, so if I had an object that was, or a VT graph that had that on there, all right, this tells me that my velocity is changing, right? I have a slope now. It was about 0, and then after 4 seconds or so, I'm at 7 or 8. All right, it's changed. I was not moving or going really slow, and now I'm going faster. All right, so this is moving up and to the right. It is the positive velocity. All right, so the slope on these things equals the acceleration. All right, so the slope on a VT graph tells me the acceleration. All right, so I look and see this is up and to the right. All right, so I know that this is a positive acceleration, right? Up and to the right. I'm moving in the positive direction with a constant positive acceleration. So this tells me that I am speeding up. Right, I'm getting faster. We can look at that and see, oh, you were at 0, now you're at 7 or 8 or whatever. Yeah, you're getting faster. That makes sense, right? I'm going away from 0 meters per second, which tells me I'm not moving. So obviously, I must be speeding up, okay, in the positive direction. I have positive velocity, right? I'm going that direction. All right, so I have positive velocity. Okay, I'm above the 0. This tells me I have positive velocity. I have positive acceleration. I'm speeding up. That applies to our same rule. If you saw another video, where the same signs, right? Same signs equals speeding up. See that close? All right. We'll say opposite signs, slowing down. All right. So same sign speeding up, opposite sign slowing down. We have positive velocity here, right? It's above the line. Positive velocity. The slope here is positive, so I have positive acceleration. I'm speeding up. I can also look and see I'm getting away from 0, which means I must be speeding up. Now, if we instead had a line that was going, use pink, this way. Now what? Speeding up, slowing down, what do you think? The exact same process. We can look at this and say, all right, this is a negative. I have negative velocity. Same thing applies. I can take the slope and determine if this is positive or negative. It's down to the right, so it means I have a negative slope. All right, so I have a negative velocity. The slope is negative, so I have a negative acceleration. That means I'm slowing down. All right, so I have negative velocity. Slope here tells me I have negative acceleration. Okay, oops, pardon me, that is wrong. Same, check my rule. All right, I'm speeding up. All right, forgive me. So I'm speeding up. So I'm getting further away from 0. I'm getting faster and faster. All right, I could look at it and see that. I could also take this information, apply my rule, and like, all right, I'm speeding up. Now, all right, so basically the same thing. Positive velocity, positive acceleration, speeding up. Negative velocity, slope is negative, so I have negative acceleration. Getting further away from 0, I'm also speeding up. Just speeding up in the negative direction. All right, so I'm going away from here, I'm speeding up. Now, if I change this, instead, I'm going this way, and I'm going this way. Now, how do we interpret it? You take the same type of approach. I have a positive velocity, all right, on the positive side. But if I take a look at this slope now, that's a negative slope. The slope of this is acceleration, because the definition of acceleration is the change in velocity over time. So the velocity is changing. Time is going by. Slope of this is acceleration. That's a negative slope. So now, that's a negative slope. And I could see it also that I was at 10 meters per second. Now I'm getting closer and closer to 0. I must be slowing down. And that works with my rule. Opposite signs, positive, negative, they're opposite of each other. I'm slowing down. All right, so then if I look here, I see, okay, I have a negative velocity. I have a negative velocity. If I take the slope of this line, that is a positive slope, so that tells me I have positive acceleration. And I can look at this, look at my rule, and say I'm slowing down. I can also look and see that I'm getting closer and closer to 0, which is 0 meters per second, which is slow and not moving. All right, then I'm slowing down. All right, so there's multiple different ways that you can understand this. All right, if you saw from class, the last example we did before the end of class, I had this angle here and then I had one angle going down there, and you had to be able to decipher between the two. That's important. All right, same thing. You just have to think, am I getting closer to 0? If I am, I'm slowing down. If I'm getting further away from it, I'm speeding up. All right, then I know if I take a look at which side it's on above 0, positive side is positive velocity. If it's below it, it's negative velocity. And then I can check the acceleration. Oh, the slope here is positive, positive acceleration. Slope here is negative, negative acceleration. So you can use all these things to interpret what these things are actually telling us. Can they tell us if we're moving towards the origin or away from the origin? The answer should be no. We don't know for certain. If we had an XT graph to go along with this, then yeah, we can use that information to determine it. But if we have this by itself, we don't know. We just know we have positive velocity, so we're moving in the positive direction, but we're getting slower and slower and slower. I don't know if this is, let's say this is my origin is 0 and this is positive and this is negative. I don't know if I'm here moving that way and getting further from it, or if I'm here moving in the positive direction, because that way is positive, and getting slower. I don't know. So I can't determine that from just this graph by itself. I need other graphs to help me or scenario to explain. All right, so constant velocity or constant acceleration VT graphs can be a little confusing. All right, the biggest thing is making sure we remember this is 0 meters per second. It's not moving. If I can keep that straight, then I can interpret what the lines are telling me. All right, hopefully this helps a little bit.